My name's Connor McDonald. I'm from Perth, which is there. How the colours might be. Doesn't show red. Okay. Let's see how the demos go. Doesn't show red at all. Oh dear. This could be fun. I'll start with a funny story. Oh, red comes up as black. Okay. I went to the documentation site at my current client recently. This is instead of my bio. And I couldn't get to the Oracle docs. It was blocked by the firewall. And so when I went and asked about the firewall, they said, well, it's become apparent that a lot of the people working here with Oracle, they're accessing this site regularly. And they're consuming a lot of bandwidth, and so we've locked that down. So I just thought I'd share that with you because I thought, that's how funny bureaucracy gets nowadays. A little book plug. We're almost talking about clone database. We're going to have some dramas, aren't we? I see half the slides.
I don't think it's your machine.
You don't think so?
Other people have had it.
Yeah, we've seen the same.
So.
Oh, well, we'll see how we go.
We just get green and blue.
That's good. Anything you can't read, I could care less. So we're talking about cloning databases today. Why? Well, here's the drama. Everyone wants good data, right? That's the thing. Everyone wants good data in their databases. And this is why in your production database, hopefully you actually have good data. We've got some data in there. Once you get to your development database, it's a plaything for everyone. So you're trying to write applications, but everyone's been playing with their dev database, and people have got surnames that does umlaut work, and they've got spaces for the surname, and the dates are all whatever people invent. And so when you're trying to build and test applications, because everyone else is messing around with your data, it's hard to build them. So everyone wants good data. So that's easy to do. What you do is you take your production database, and I'm sure everyone does this, and they clone it every once in a while to their development database. And it's, with RMAN, once you got to about 10G, it was really easy to do. It's a one-liner, duplicate the database. There's one small problem in that approach, right? And that's this person, right? This person is the storage administrator, right? And they sit about here in your organization, right? They sit just slightly above the CEO. And it's funny how they've literally become the most important person in the organization. They'll clone your database, sure. They'll clone it once. Right? And the problem is everyone wants current data. And so what happens is when your production database gets deployed and it's small, they'll happily clone it nightly for you. Yeah, sure, every night we'll rip it back. There's an arrow saying nightly. Nightly we'll clone it back, right, to development for you. Then when your production database gets bigger, well, they'll clone it weekly. Some text you can't read. Weekly they'll clone it for you. And then when your production database actually accumulates to a reasonable size, it becomes an annual kind of experiment. Right? And that's what happens. Storage admins just go, nah, we can't afford that kind of space. We can't clone it every day. It's too much drama. And so you get this, how that never. Right? And who has here? We got production databases, and they never get cloned back to test or development nowadays because that's claimed to be too hard or too big. And the problem with that is everyone wants full-size data as well. Right? And so what happens is here's our annual copy from production to dev, and they just won't let you do it. Right? And why won't they do it? Well, they say, well, we haven't got the space. What we'll do is we'll give you a subset of production, and we'll clone that back to dev for you, and you'll have to make do with that. And you sort of end up between a rock and a hard place. Right? You've got this thing where you've got this production copy, and I'm going to copy it to a small or cut down version back to dev. Well, to do that normally involves a lot of CPU because you're doing things like, you can't just copy the data files anymore. Now you're doing data pump or export import or CTAS, etc., or transportable table spaces if you're lucky. But generally you're burning a lot of, machine firepower doing stuff that really is of no value to the business or it's really just to give you a cut down version of the database. The alternative is to spend bucket loads of cash on getting enough disk space here, which your storage admin's not going to let you have anyway. So you're sort of stuck. The moment you adopt this principle, right, it's just not a good use of your time. And there's risk involved. The moment you have small versions of data in your development databases, all you've done is really introduce a massive amount of risk into your development workplaces. Because you'll go out and build, this is my latest new PL/SQL procedure, and it does select star from every piece of data we've ever known where unindexed column equals 10. And in development, hopefully the time comes up, that runs in 0.03 of a second. That's sweet, because my development database is 1 gig in size, right? And so we roll that out to production, and this happens. We miss the fact that we've written bad code when we start having small-sized databases that aren't in production, right? And we have these problems. Combined with that is everyone wants their own data, and that's the big challenge, right? This is what's happened in the development world, right? Source code control has come in. Do you remember source code control used to be you would lock a piece of code, you would work on it, and then you'd put it back in source code control. That metaphor has evaporated in the modern world. Nowadays, it's everyone takes access to the same source code all the time, and we just check it all back in, and some magic merges it. Right? And that's what's happened. Like, everyone wants version control of their code and version control of their data. So this is the ideal, and there are little arrows you can't see. Right? Everyone wants prod, but Mike wants his copy of prod, Sue wants a copy of prod that she can play with, etc., etc. We all want a copy of the production database. And what typically happens is the absolute opposite. Now, for developers, all get told they have to share the development database. And of course, you have to start getting emails like this. Mike, to all the developers, who mess with my data? Someone goes and rolls out a new version of a program, it breaks the build, and everyone's pissed off. Right? And that's the problem when you start sharing common data sources. And this is, one of those quotes, increasingly environments are getting more and more bigger, and they're becoming a problem, etc., etc. So there is a solution. Right? And the solution is CloneDB. Right? And that's what we're going to talk about today. It's free. Now, let me repeat that, slowly. That's an Oracle feature that is free. Right? That makes it special just for the sake of that. Right? There aren't many features that Oracle do that are free. Okay, so you're already ahead of the game just by having this. It only has a single prerequisite, that you use DirectNFS. Right? Now, what does that mean? Well, I'm going to have a little segue here. Right? We're going to park the CloneDB talk for a second and talk about NFS, because that's the prerequisite for CloneDB. Let's talk about NFS. The world is full of fibre, right? Fibre channel, right? And we're obsessed with it, right? And it became the big thing. And let me give you a little bit of a backstory about how I came to be in the IT industry. In the 90s, I worked for a company called BHP. They're a mining company in Australia. And we had a mainframe system. And like all companies in the 90s, you had a mainframe system that's working fine, but the client-server revolution came, and so we started migrating to relational database. And we chose Oracle. Thank God, we actually wanted to choose Ingress. Right? And we all of us as developers loved Ingress, and so we wanted to choose Ingress, but we found out our project manager was sleeping with the Oracle sales consultant. And voila, we became Oracle people. But that actually worked out really well. And this is what everyone did. You went out and bought, in those days, a little Sun box or some little HP box, or people that ran Oracle, and it had some disk inside it. And then, when that one filled up, and you had another application, you built another little Sun box, and you put some disk in that, and you just kept on going. And you had lots of little servers, each that had an Oracle database running on it. And then something terrible happened, absolutely abysmal, right? This terrible thing came along called a SAN. Right? And that was just a disaster. And the reason it came along was that the claim was that if you had local disk in these servers, then it would have problems with that. It was hard to manage. And this was the standard slide when SAN vendors were there. They're going, you've got all this unutilized free space in local disk that this machine can't access that. It's all catastrophic. What you need to do is it's hard to manage. It's inefficient. And there's sort of some truth in that, sort of. And this is the only thing I really saw a benefit of in SAN's having, was that eventually as your disks filled up, you had to go buy new disks. And in those days, you'd go back and say, can I get 10 SCSI disks, please? Right? And they go, we can't give you SCSI disks because you bought fast SCSI. And that's obsolete. Now it's fast wide SCSI. So you need to buy new storage. Right? And you go, okay, so you go buy that, and they go, well, actually, no, it's ultra SCSI now. Right? And then it became ultra wide SCSI. Then it became ultra 2 SCSI, ultra 2 wide SCSI. I'm not making this stuff up. These are real technologies. This one I might have made. But that's pretty much where it went. Like every time you went to get storage, your gear was crap and you couldn't buy it. And you had to go buy new storage again. So the claim solution was to take all that stuff and migrate it all into this consolidated storage, and somehow that would fix everything. Now consolidation, in theory gives you some performance and ease of management. Those are claims. But really, most people with SANs have just had a lifetime of problems with them. Right? And the problem is this, the N. The N in SAN was the problem, because it had a server, and it used to have disk here, but now it's way over here, separated by fibre. Right? Now, in the 90s, that's fine, because your choices were fibre at, say, a gigabit per second, or Ethernet at 10 megabit per second. That's like 100 times faster. So, it was all about fibre. And people used to have that great argument, disks are slow, and fibre, like it's the speed of light. It's infinitely fast. That was the claim, it's fibre. It looked cool. Ultimately, that was a bad metaphor. A modern disk drive can do about 150 megabytes per second. Right? That's what just go down to the local Radio Shack and you can get a disk off the shelf and it'll give to about that kind of throughput if you're really cranking it out. Now, as servers have got incredibly powerful and these disks have got bigger and more powerful, we were still trying to pump that stuff through 2 gigabit per second fibre. Well, 2 gigabit per second gives me 250 megabyte per second, and that's why when you're talking storage, always be careful with your little b's and big B's. So 2 disks can saturate that. And what do you got in a SAN? Hundreds of disks. Right? So you've got all this disk and firepower, and you're trying to squeeze it through this little, 2 gig fibre channel. It just killed you. The other problem was you had to provide that data. And this is one of Kevin's favourite quotes, and I use it all the time. To read from disk takes a lot of CPU. And it sounds weird because everyone says, I got CPU and I got disk over here. But to read from disk, you have to actually chew through that data. And if it's Oracle, you have to extract the blocks and find the rows, etc. Accessing storage fast is a CPU issue. And what happens when you bought a SAN? It had 1 billion disks inside it and a little tiny Linux kernel, a little tiny CPU trying to provide all that data outwards. And if you've ever used any of these consolidated storage solutions, when they stopped running fast, it was very rarely the disks that were maxed out. It was the little CPU on the SAN that was actually maxed out. So the problem with all this is, you go to your storage admin and say, there's a problem with the storage array. And he goes, it can't be slow. Do you know how much we spent on that thing? It's impossible. We spent millions of dollars. Advances have come along. Fibre got better. Fibre became 4 and 8 and 16, etc. But we need, you can just see the B there. We need gigabytes per second, not gigabits per second. That's what we need. And that's for disks. Now that the world is flash, it's just going to get worse. And you see a lot of the vendors now, they're putting flash back in servers, not out on storage arrays. So separating server from disk can, not is, but can be an expensive mistake. And all it really does is create this hierarchy in your organization. The irony here is, what's happened nowadays? We've got Exadata. This magic secret sauce in there. We've got the big data revolution. It's got all these, the 4 Vs, all that rubbish. Big data boxes. What's their magic? They've come up with this incredible innovation. And what we'll do is we'll move the processing of data back to where the data is. We'll take stuff that used to be consolidated and we'll push it out to here. And they're going, isn't this the coolest brand new idea you've ever seen? I'm going, well, that's exactly how it was 30 years ago. But that's, we're IT, we reinvent things all the time. Now, having said all that, consolidation makes some sense if the storage tier offers you something, right? And, some storage tiers do. You get all these kind of things, snapshots, clustering, site mirroring, etc. So don't get me wrong, I'm not saying you shouldn't ever have consolidated storage. I'm saying just doing it for the sake of having consolidated storage isn't maybe such the best idea. Successful vendors did this, right? That's the NetApp share price over the last 10 or so years, okay? NetApp did very well. Let's get back to NFS. Does it give me something? I've just said storage consolidation is cool if it gives you something. So let's talk about NFS. It does give me something. It gives me CloneDB, but it gives me more. One, it's a shared file system. You used to have to go pay for clustered file systems like Veritas and stuff like that. NFS, it's basically a shared file system straight off the bat. That's awesome if you're using rack. If you've got a 20 node cluster, everything can be shared for free, just NFS. It's Ethernet. Ethernet is dirt cheap. You can buy a 10 gig Ethernet card now for a couple of $100. You go try buy a fiber channel host-based adapter and a fiber channel switch for $100. You're going to be out of luck. You don't need any of that kind of high-end technology. So why isn't everyone using NFS? Because very few people do. Well, people say Ethernet's slow, and they used to quote this argument: Ethernet gigabit per second, fiber channel 4 gigabit per second, etc. And when this became 10 gigabit, well, people said, well, we've got 16. Well, that was easily fixed, and this has been easily fixed for a long time. You could take, a quad gig, quad 4 1 gig Ethernet cards and make it a quad, right? Just with bonding. And the technology's advanced. People still think of Ethernet as 1 gig. Nowadays, a little bit more 10 gig, but it went 10. 40 is just around the corner. You could do 40. You could do 4 10s bonded, but now 40 itself. 100 gig Ethernet is coming, and terabit Ethernet is just around the corner. It seems to be advancing faster than where fiber seems to be going. At Oracle World last year, I went to a talk by Thomson Reuters about direct NFS. They're using 6 10 gig Ethernet cards and 10 gig Ethernet all sitting under direct NFS. They've ditched fiber. This is where you want to be doing. It's very cool. So why direct NFS? Well, NFS is slow, and that's a valid point. Why is NFS slow? Because this is how it's generally implemented. You have some sort of software layer like Oracle, it talks to the OS, it maintains an NFS client cache, and it finally talks to the disk. That's a lot of layers on the onion to talk to a disk. The solution is easy. Oracle gave us a free tool called Direct NFS. It simply says, well, we'll look after it. We'll do it. Right? And Oracle has NFS support direct in the kernel. It does the talking to the disk. Direct NFS absolutely rocks. Right? Here is a benchmark done by NetApp of direct NFS versus 8 gig fiber channel. And this isn't trying to say that this is bad, it simply is a reflection of it's pretty close to wire speed in both. Right? This is about 20% faster because it's got about 20% more bandwidth. But direct NFS, you can see, will outdo fiber channel simply because it's got 10 gig over 8 gig. Right? So direct NFS, virtually no overhead. So if you've got no interest in cloning, think about direct NFS just as its own right. We use direct NFS at my current client. We're a rack system, and it's sweet. The best thing is just trying to shut the fiber fanboys up. That's really the aim here. Back to CloneDB. That's the background on direct NFS, trying to convince you to use it. It means that Oracle now is controlling the I/O, and when you control where writes go, voila, you have CloneDB. Now I might have skipped a few things there. This is what we're trying to do. We take our production database. We do an RMAN image copy, right, otherwise known as a nightly backup. You guys are doing this already, right? There's no cost to you, that's what you do backups. And then you do a thing called a clone with direct NFS. And it still looks like, well, I've got 3 copies of the database. But what have you sold me so far? Well, this is really what it is. Your clone database consists of the image copy plus a little bit extra. So I haven't actually copied my backup to another copy of the database, thus raising the ire of the storage admin. I'm going to use my RMAN image copy as the clone. Now, what's this little bit here? Direct NFS COW, right? Cow. Copy on write. So this is what happens. The clone of your database is your nightly backup, but it's read-write. That's the real magic here, right? It's a read-write copy of your database that is also your backup without impacting the integrity of your backup. Right? What happens is the backup stays read-only. As it's open to read-write and you allow people to make updates, those deltas are written to a separate area. So what happens is I connect to my clone database, I do an update. Here's my read-only image copy backup, which is still a totally valid backup. I'm updating ename of Sue to something else. The delta is written and disappears off into the ether. That's data corruption. So over here we have a picture of an employee name called Joe, but the read-only copy stays as is. It's just an RMAN image copy. You can even sit on read-only storage, and the deltas get written to the clone database. So the initial size of your clone database is 0, right? Because you've got no deltas, it's 0. When you do a select star from emp, what happens is it accesses all the blocks in the read-only, but as it encounters blocks that are actually being updated, it goes and accesses those deltas in the clone. Just like normal snapshot technology in storage layers, but it's done with a database. And then the other blocks just are read as per normal. So you've got one clone like that, and of course I can have as many clones as I want. Right? And they all can run off this single RMAN image copy. You can just start up as many clone instances as you go. How to do it? Well, there's a sort of under the covers concern, because if you go onto Metalink, there's a document ID about it. There's very little documentation about it, and it says to do cloning, you have to use this magic Perl script called CloneDB. And you think, ooh, I wonder what's in there. It's not any magic at all. Let's do a demo. Now, the reason I thought I'd do a demo is I went to my little laptop here and I was looking at the history of talks I've done. And I thought, no wonder I get no buzz anymore from doing presentations. I've just been doing this for too bloody long. So the way to get adrenaline back into myself, live demos in talks. So that's what we're going to do. All right, so let's see how we go. This could go catastrophically wrong, but that'd be cool. Hopefully we can be able to read it. Was demo 1 I'm running? I hope so. So, how do we have DirectNFS on? It's pretty easy. Right? There's an actual Oracle library that I'm going to have to break the microphone. Okay, so what we've got is underneath Oracle bin on Windows, and Oracle lib, Oracle home lib on Unix. Effectively, we have Oracle data access layer, and you can simply replace the default one with the NFS one. And there's a make command, you can do it, and it's that easy. So you shut your instance down, flip on DirectNFS, turn it up again, right? And you now have DirectNFS support. You don't have to use it, but now you've got support for it. So that's nice and simple. I have to go back now because I need to press the buttons. So here's my existing instance. DB, I'm doing this under 11.2 because it's a laptop, I can't fit 11 and 12 and other things on here. And you'll see why I can't fit it on shortly. So I'm on the database called DB11.2. Right, I fire up RMAN, and just to show you, I'm doing a list backup, I think, somewhere, and I've got a backup. Right, it's just an image copy backup of my system. So list copy of database image copy. So there's my image copy backup that I took ahead of time, so not to bore you. And there's my backup. Okay, so you can see it's about 20 gigs in size, a little less than 20 gigs, this database. So let's start building our clone database. So our first clone database is going to be C11.2. Right, I'll shut down abort it, make sure it's not running. And here is the init.aura for that new database I'm going to create, or new instance. It looks just like any old thing, but here's the key. CloneDB equals true. That's the only thing I have to do that tells Oracle that this is going to be a clone database. So let's start it up. Bear with me, it's a laptop. So I'm starting it up in no mount. So at the moment it's just the instance, right? There's no control file or anything, right? And it's about 1 gig in shared in memory. So just doing a tail on the alert log, the key line is up here. This is how you tell if DirectNFS is activated, right? It says I'm using DirectNFS library version 3, right? That's the key line in the alert log that tells you you've configured everything correctly. So let's create a control file, right? So these are the references to the RMAN image copy. Right? So these are references to my read-only file. I've created a control file, right? And it says this would be a bad idea to open this database. This is the only place where you have to be careful. If I did alter database open here, because that is the RMAN image copy, I've immediately broken that image copy because I've opened those files read-write. So at this point, I don't want to open it read-write. I need to tell Oracle that this is going to be a clone system. But it's just normal create control file, just like normal. Here's where the magic happens. Using this routine, dbms dnfs, I'm saying, well, this is the RMAN image copy. Don't actually write to that. When I have some deltas, write them to Y drive, C112, etc. Just doesn't fit, does it? Scroll that across. So yeah, so one for each file. Follow me so far? So that's the particular piece of magic. Now, you're thinking, well, Y drive, where's that? Well, guess what? I haven't got one. So how on earth is all this working? Let's have a look at the special file for DirectNFS. It's a file called aura.nfs tab. Right, it's just sitting in my Oracle Home DBS, and it says, I've got a server called host12c, that's just a name I picked out of thin air. That's its actually IP address. This is how I get to it from this machine, and Y drive is actually disk2 clone on my other box. Right, this is an NFS mount that I'm going to write all my deltas to. And that's the only thing you need. You must have a direct NFS mount that you can write your deltas to. etc., etc. So I query DNFS service and it says, yep, that's all registered fine, right? You'll be using host 12c and this particular export. So let's flip over. Where is that box called host 12c? Well, here it is here. It's a little, right? It is a little virtual Linux box running on this same laptop, right? So I needed a box that can do NFS server. A Linux box will do. So you can see under disk2 clone C112, the name of our clone database, it's created these files. And the first thought you think is, oh my goodness, it's created 20 gig of files. Well, that's no good. I was looking for a nice little small one. That is just a representation of the files, right? They are sparse. If we run do on them, their actual size is 8K. Right? So it's effectively pre-allocated, but there's actually no consumption of space there. They're only 8K in size. That's where all my deltas are going to be written to. Now back to the PC. So, my database now currently has a control file. I fire up rman, right, and recover the database until 10 minutes ago, right? And it's basically rolled through some archive logs, and it's done, right? So this is stock standard database recovery. Create a control file, roll forward to a certain point in time, and open the database. There you go. I have a cloned database. Right? Let's add a temp table space, which is what you do when you recover a database. You can see that Oracle thinks it's 15 gigs in size. So everything inside it looks as per normal. Yeah, let's create a table. I'm not trying to do smoke and mirrors here. It actually works. Right? I can do a count. Let's go back to PC demo 1 on Linux. And because I've created some data, these files start to grow because these are the deltas. So there we go, a cloned database. Right, I can delete, etc., and we're done. Right, so this machine now has a cloned database. Let's go back to the slideshow. So what does this magic Perl routine do that you find on Meddling? All it does is generate the SQL I did there. It generates a create control file script, generates a recovery, an add temp file, etc. And generally it generates it badly. It misses things out and stuff like that. But that's all it does. It's just a text parser. So write your own like that and it's trivial. How are we going for time? Okay. It's flexible in terms of point in time. Let's go to another demo. Let's do demo 2.
Connor?
Yes.
Could you have the database or the copy of the database on NFS?
Yes.
You have it local here, don't you?
I have it locally, but yeah, you could be on NFS as well.
Yeah.
It's makes no sense. So let's do our next clone database. This one's C112 number B. Right, so shut down abort, start up force.
So the original database actually is a normal database. It can be any storage system.
Yep, any database. But we will cover that. I'll talk about some of the options you'll see shortly.
Okay.
So here's our second clone instance. Create control file as before. Direct NFS stuff as before. I'm leaving out some of the pauses. Recover it. Okay. Why was this recovery special? I recovered to a different point in time. So I got my image copy backup I took on Sunday. I want to have a clone as of Monday, one of Tuesday, one of Wednesday. I just rattle them off as much as I want. Right? That's why this recovery was special. Right? Open reset logs, etc. PC demo 2 on Linux. And you can see we've gone to C112B. Once again, it looks like it's big, but it's just a few megabytes in size. And we're done. Right, so now I have 2 clones on this system, both now at different points in time, both working off that single image copy backup. Slideshow. And it's fast. Let's do another couple of demos. More PC. Demo 3. Right, so less pauses in this one. This one's going to be C112C. Right, off we go, start up force. Come on, PC. Right, we roll the way through, reset logs, yada yada yada. There's another one. Right, what was that, 10 seconds? Tell you what, let's work it out. We'll turn time on. So it started at 4:36:29 in the morning. That's because this is on Perth time, this laptop. And we're done. Oh, so what was that? 8 seconds to clone a roughly 20 gig database. That's not too shabby on a laptop. Now if I can find slideshow. So this poor laptop, 5 20 gig databases on it, because I got DB, the original version of the database, and I got clone 1, 2, 3, and 4. 5 databases, each 20 gigs, and this laptop doesn't have 100 gigs of storage on it. Plus, I've got a VM running to be my little direct NFS server. Right? It's uber cool, this stuff. Now, you're going, thanks a lot, Connor. You know, if I'm using NFS storage, I am set to go. But you know, I'm one of these people that got suckered by SAN vendors. You know, and so we're all running on a SAN. It could still clone, no problems at all. Right? The only thing you need direct NFS for is the deltas. So you can just as easily have production on a SAN, your ArmEdge image copy on a SAN, and even your clone reader logs on a SAN, as long as the deltas get written to a little direct NFS somewhere. So as long as you have a Linux PC somewhere in your organization that can share out an NFS mount, right, you can clone till the cows come home. Very cool. You're going, oh, but we're on Windows. Well, so am I, right? You can still clone. You know, it works on Windows. You've just seen here. Right? I didn't have to install any NFS software, etc., because it's Oracle Direct NFS. Right? Windows works just as well. Now, a real customer, I work at WA Racing, where we're a gambling organisation in Australia, and we do this nightly. Right? We have an AIX box at the moment, and yeah, every night we take our development, which is like our main development database that everyone shares, but people can have a clone of that if they need to do some testing or something that might be destructive to the rest of the development environment. And we do it every night. We just take an image copy every night and roll it in. There are literally no limitations. All that really matters is, do you have enough RAM to keep firing up instances? This laptop's got about 12 gig of RAM, that's why I've stopped it at 5 clones. But you just keep cranking them up. The available disk you require is very small. Most development environments, I find, people do a little bit of test data, but they're really just compiling code against it, or compiling pure SQL code. You're not going to do a lot of deltas in there. Available licenses, obviously. Every box you actually fire up a clone instance on needs to be licensed. But if you're on x86, which most of us are, that's the real winner, because guess what? Every developer has already got a lovely x86 server on their desktop. Right? That's what it is. You know, a modern PC is awesomely good as an Oracle database server. Just fire up a VM and run the clones in there. For discussion, you know when you go to OTN and it says you can download any Oracle software you want and play with it for free? Well, the question that we asked was, if we have our database server on AIX and we want to give a clone to all these people on their own desktop, do we have to license each person's desktop if it's for this purpose? We asked, I made an official question of Oracle, and they said no. We said, you know, so we seem to be okay. They said, as long as you are just developers are using these clone machines, right, just to actually tinker and play and stuff like that, and that eventually their code goes back into the main development database and that box is licensed, which obviously it is, right, then we're okay. So we made that official question so people can clone on their desktops because it's just a clone. So that's awesomely cool.
You got that right?
We got it in writing.
Wow.
That's very cool. So let's move on to 12C. Cloning in 12C is trivial, right? But potentially space hungry. Why is it trivial? Because we've got pluggable databases nowadays, right? And it really is easy, easy, easy. You want to make a clone of an existing pluggable database? Create pluggable database, my clone from an existing one. It's that easy, right? And you're done. The problem that is, what have you just done? You've got a machine which has one pluggable database in a container. The cost for that above your normal license option is 0. The moment you create a copy of that, you have 2 pluggable databases inside your container. That is a separate cost option. You've just been slugged for about $25,000 per CPU. That's expensive. Let's do a demo. It's got the Linux box there, don't we? We'll go back. What was it? Demo 1. I hope so. So let's see this in real life. Right? Here's my Oracle 12 instance running under Linux on this VM. That's another database on this poor laptop. It's got the typical seed and a pluggable called PDB12. Right, I'll close it so it becomes read-only, or open it read-only. And this is how I do it. I'm going to choose how I'm going to convert my file names, so anything PDB12 becomes PDB12b, and create pluggable database 1 from the 2. It's that easy. Why is this taking so long? It is a real copy. It is copying 20 gigabytes from here to 20 gigabytes over there. That's the space hungry part. By default, that's what it costs you. So not as good as DirectNFS. When you've done your pluggable, you end up with your original was still read-only, your new one is just mounted. So there's a list of all the data files. It copied all the PDP data files to PDB12b, and we open it read-write, and it is just a normal database. And off we go, change to it, create tables, etc., etc. And we can close it when we want to get rid of it. We close it, drop it. So it's like table spaces on steroids. Yeah, it's that easy. That's really cool. Oops. Back to our slideshow. So how do you avoid that space consumption? Because that's all well and good, makes your life easier to do it, but now I've got multiple big copies, and if you've got a terabyte database, it's going to take some time to make another terabyte database.
You have to
Well,
take it down.
you can do snapshot copies, right? Time for a demo. Right, let's try close it again, same process, open it read-only. Let's try do this as a snapshot copy. This is totally supported. It's effectively just doing deltas. There's one slight issue. You'll get this error. Right? It all goes belly up. Why? The underlying storage is not supported for snapshot technology. In Oracle 12.1, these are your options. Right? It has to be a ZFS appliance, a NetApp appliance, or using ASM file system. Now, very quickly after 12.1 came out, they relaxed that. They said, as long as you're running ZFS, that's a cross through there, sorry, then you're good. Right? You still have to have that kind of technology. In 12.102, the docs say this, which is, as long as you have anything which can be supported under DirectNFS, any file system, you'll be able to do snapshot copy pluggables. Now, I've yet to verify that, but that sounds awesomely impressive, because that's now effectively a one-line command version of clone database in 11 supported using this. The reason I reckon they've made this relaxation of the rules is because the moment you create more than one pluggable, you're paying an extra license fee anyway, so they're going, life's good, the money's rolling in.
I did test it out, it does actually work.
There you go, it works, right? So for a small fee of $25,000 for a CPU, yeah, you're rock and roll. But if you are a company that has already licensed multi-tenant, this is gold. This is awesome. One-line commands for snapshot copies, fantastic. So far you're going, yep, I'm loving what you're selling, Connor, this is fantastic. 2 minutes to clone databases, I'm thrilled. But it takes me 10 hours to do an image copy of my database, thanks for nothing. Well, there are technologies to fix this. One is block change tracking, which I hope everyone is using because it's awesome. Full backups are slow, we all know that. And back in 10G, or whatever, 8.0, when RMAN came out, we said, okay, that's fine. Cop the hit, big slow full backup. Oh my God. But that's okay, because I'll use incrementals, and they'll be fast. And then you realize that they were slow as well. In fact, they took just as long as a full backup. Why? Because an incremental still had to read every file, every block, and say, well, has the SCN changed? That means something's happened, I need to back it up. Incrementals gave us smaller backups, but they were still just as slow. The easy solution, you simply turn on block change tracking. It's really cool. It's very low risk because people say, what's the overhead? If I'm tracking all these blocks, is it going to hurt me? Well, very, very unlikely. And the reason for that is, it's done with a background process called CTWR. The cost, I reckon, is zero, maybe inverted commas. Reason one, if you're doing lots and lots and lots of block changes, and that's your worry, I'm doing block change tracking, I'm changing lots of blocks, what's going to happen? Well, you're generating lots of redo. And I can tell you right now, redo is a hell of a lot more complicated in terms of managing than block change tracking. Right? If you're thinking about, oh, I'm absolutely belting the system with LogWriter, this is just going to fade into insignificance compared to what LogWriter is doing, because really LogWriter is very complicated. Reason number 2, it's asynchronous from the user, which I like. Right? What happens is, here's you make changes, you're not going to see any of these arrows. Well, you're not, oh, life's cool. You make changes in the buffer cache, right? DB writer will eventually take care of writing them to disk. It'll let CTWR know, or similarly, and it'll take care of writing it to block change tracking, or similarly checkpoints will also take care of that. So it's totally asynchronous from the user. It's not going to affect their response times. It's not going to have an impact on your server unless log writer is already destroying your server, in which case you have nothing to worry about. Number 3, it's all managed in memory. So there's a whole lot of memory structures to control it. I'm going to run out of time, so I'll flick through some of this. A lot of $X tables you can play with. It's space efficient, which is nice. It's not like tracking every block and writing those blocks to a file. What happens is data files are represented by 32K size chunks, and they're the things that get managed and controlled and written to disks. I'm not going to bore you with detail. There's a really good, awesome white paper on the Pythian website which describes it in wonderful detail. It's such a good paper, MetaLink stole it and put it as their official one on MetaLink, so it's really cool. Demo. Now I've put an asterisk here because this isn't a real demo, because if I'm going to show you block change tracking, I need to take a full backup first. That I'm not going to do and bore you with. So let's assume we're running this real time. Right? Here's my incremental level 0 backup. It actually started at 13:58 and finished at 14:02, roughly. So it took 4 minutes 36 seconds. Let's assume that demo has just been done in real time for you, but we're going to flip through. Let's do the real demo, the real magic, which is, let's back up, I hope it was demo 5. Let's back up my 20 gig database using block change tracking. Oh, it's done. That's the cool thing with block change tracking. That's an incremental backup, there's very little changes done. It is instantaneous. It's basically proportional to the number of blocks you've changed, which in my case is virtually nil. So yeah, block change tracking, turn it on tomorrow, forget about incrementals being slow. It's very cool. And you can see, it just did a normal incremental backup of 5 megabytes. The second issue, if we're going to get CloneDB really working for us, is rolling recovery. You've got these super fast incrementals. You're going, fantastic, I'm going to take an image copy like on Christmas Day, and I'm running incrementals for the rest of my life because they're going to be so fast. What about recovery? Because now you've got this kind of scenario. I want to recover up to here. I took this full backup ages ago, and now I've got to roll for these billion incrementals I took, right? Because you believe what Common told you. Well, that's going to be a pain to roll forward Monday's incremental, Tuesday's incremental, etc., etc. But instead of recovering from a backup in Oracle, you can recover a backup in Oracle. And this has been there since 10G. You recover the copy of your database. And so what happens is, on, say, Wednesday, I take Monday's backup and say, please apply Tuesday's incremental to it. And now I have an image copy as of Tuesday, without actually taking the full image copy on Tuesday. So take Wednesday's incremental and put it on top of Tuesday's full backup, and now I have a full backup as of Wednesday. And that's a great way of just rolling it through forwards. So I can choose how many incrementals I'm prepared to roll through, right, etc., etc. So, time for a demo. I think this is the last demo. Oops, wrong one. So, recover copy of database with tag whatever, it does all this, and recovery is complete. I've taken my Monday backup and rolled it through Tuesday's changes. And now it's Tuesday's incremental, Tuesday's full backup. I think we're just about done. And that's how it works. So you could do something like this. Oh God. You could have a full copy of the database, right, and I've given it a tag of rolling, and the tag name determines how these things work. A full copy of the database tag day -3, which is recovered up to 3 days ago. A full copy of day 7 recovered up to a week ago. I can have lots of different full copies at various points in time and use them for cloning operations. So bringing it all together, which means we're just about done, and I'm just about out of time. There's my production database. There's an invisible red arrow. Take a copy of it once. Well, I'm actually going to take 3. A full image copy, one that's going to be kept, in fact, one image copy copied 3 times. Then I'm going to apply my super fast incrementals to them, right? So that's going to be cost me virtually nothing because I'm using block change tracking, right? Incrementals to each one. And what I'm going to do is, Right? What I've got here is, this is an image copy taken today, this is one from 3 days ago, this is one from 7 days ago, and they all become great sources for me to give people clones. So I'll take the one I took back up last night, and I'll give people 4 clones of that. Right? The one from 3 days ago, so someone says, oh, I had a problem in production last Friday. I don't know what it was, but we had a data corruption. Can you give me a copy of the data as it was 3 days ago? And you go, no problems, here's a clone. And then someone says, I'd like to copy the data as of last week because last week's month end didn't run properly. I'd like to do some work on that. No problems again. Right? And of course, each of these clones are all infinitely small. Right? And there's no limit on them. You get fast backups with blockchain tracking, easy point-in-time copies, unlimited number of clones. What is not to love about this technology? Right? And it's free. I want to repeat that. That's free. So, in all seriousness, I make light of some of this stuff. The reality is, there are no more excuses for not having literally almost no cost backup once you've done the initial image copy, right? No limits to how many clones you can give to people, right? And just unlimited potential with this facility. Once you get into this, you'll be amazed how cool it is and how wonderful it is. And what happens is you end up getting so many clones and so many requirements and so much value out of this. What you might find is you need to manage the clone environment. And once you get to that level where you want to consider more rigor, right, that's where things like Delphix and stuff come in. I don't work for Delphix, right? I'm not paid by them to say this, right? But CloneDB is awesome, but it's too awesome. Right, you end up with 1,000 clones, and people are going, oh, I want clone number 712 taken back to last Tuesday, please. And then, oh, it's all, where was that created? Right, that's where solutions like Delphix will sit on top of all this and manage it and possibly even add more value. Okay, so they're not competing technologies; they're complementary technologies. By now, I know you're just going, God, if I have to see one more slide, I'm going to vomit. So you're ready for a beer. Hopefully, I've got us back on track, just about. My name's Connor McDonald. Thank you so much for your time. Feel free to tweet me or send me afterwards.